Hi, I'm Ilan Shaya, CEO of ICS Security, a company that develops security measures for industrial control systems. I have more than 20 years of experience in industrial control systems and securing them. I serve as a consultant and designer for governmental entities and enterprise customers such as the Israeli Air Force, such as the Weizmann Institute. Today I'm going to talk about the 10 commandments of protecting your control network and assets. Okay, so let's begin. Many of SCADA critical components that operates today do so in a context that's completely different from the one they have been designed for. They're exposed to the internet with obvious security risks. We will now explore different architectures and provide different suggestions for designing a secure ICS architecture. What you can see here is a typical ICS architecture, by the way, ICS Industrial Control System. We can see here the corporate network, the industrial network, and we can see the HMI, human-machine interface, PLCs, sensors, pressures, pumps, flow rates, etc., etc. There are many industrial control systems that are isolated from the corporate network, but others are not. In some cases, the industrial control system is connected directly to the internet. For example, for integrator support and for remote clients. We will now explore both cases. The purpose of connecting industrial control system to the corporate network, usually for CRM purposes, sharing information, sharing process information. 10-20 years ago, the processes and the recipes were handwritten and they were transferred to the operators in order to create the recipe. Nowadays, as industrial control system develops and becomes more and more sophisticated and technological, the CRM systems that are located in the corporate network are sharing information and transfer the recipes to the industrial control system. So in that case, the control system has at least one exposure to being attacked. So let me share my experience of what steps we can do in order to mitigate as much as we can the exposure of cyber attacks in industrial control systems. Commandment 1. Identify all connections to the SCADA network. Conduct a threat risk analysis to assess the risk and necessity of each connection to the SCADA network. Develop a comprehensive understanding of all connections to the SCADA network and how well these connections are protected. Identify and evaluate the following types of connections: internal, local, and wide area networks, including business networks, internet connections, wireless networks devices, including satellite uplinks. Some of the facilities are still using modem and dial-up connections. Identify internal connections. What we can see here is a simplified industrial control system. And we can see here serial network as well as Ethernet network. We can also identify small networks that are connected together. Identify external connections. There are some enterprise customers that has multiple remote sites that are connected together. In order to display all information in the main control system, it must be connected together. So we can see now there are many requirements to connect your network to the internet or to other network or to the corporate network. Commandment 2. Disconnect unnecessary connections to the SCADA network. Isolate the SCADA network from other network connections to as great a degree as possible. Any connection to other network introduces security risks. In case of high need to connect the control system network with the enterprise network, there is a need to use a DMZ and data warehousing. Security assessment for the remaining connections. Conduct penetration testing or vulnerability analysis for any remaining connections to the SCADA network. You don't need to do it by yourself. There are many companies that conduct penetration testing for industrial control system. Make sure they are specialized in industrial control system. They have blue team, red team. This can be done easily, so implement that. This is very important. You will be surprised to know how your network is exposed or not. I want to emphasize, SCADA network is only as secure as its weakest connecting point. You can implement a strong cybersecurity strategy. You can implement firewalls. You can implement data diodes, DMZs. But if you have only one weak connection, for example, for remote support for your integrator, so it's actually all your control system is weak as this simple connection. So you need to upgrade all your connections in your control system. It's essential to implement firewalls, intrusion detection systems, and other appropriate security measures at each point of entry. We'll further explain later. Commandment 3, hardening by SCADA system. System can be exposed to attack through default network services. Remove or disable unused services and network daemons to reduce the risk of direct attack. SCADA servers and clients does not need any application or software but the HMI software and its drivers and SQL Server databases. So there is no need for any service to run but the HMI services. So if you use Sparta, for example, Sparta is blocking any other process from running but the HMI processes. For a new service, a threat risk assessment of the consequences of allowing the service or the feature must be conducted before adding it to the system. Commandment 4. Proprietary protocols are unsafe. Do not rely on proprietary protocols or factory default configuration settings to protect your system. We all know that Modbus protocol is commonly used between two vendors, two PLC vendors, for example. We also know that Modbus is the least secured protocol. So my suggestion is not to use Modbus at all, to use Profinet, to use OPC UA, or to secure the Modbus if you must use it. Demand that the vendor disclose any backdoors or vendor interfaces to your SCADA system. By the way, we have Sparta, which is a security add-on for Ignition. Commandment 5. Implement security measures provided by the system vendors. Most systems in use have no security features whatsoever. SCADA system owners must insist that their system vendor implements security features in the form of product patches or upgrades. Some newer SCADA devices are shipped with basic security features. So ask the vendor if he has the same device or the same license with a security feature. Commandment 6. Establish strong controls over any medium that is used as a backdoor into the SCADA network. Strong authentication must be implemented. Modems, wireless and wired network represent a significant vulnerability to the SCADA network and remote sites. As technology progresses, people, plant owners, system integrators uses more and more mobile devices to reflect their control systems in their cellular or tablets, etc., etc. That require from the control system to have wireless network. So if you must use the wireless network, there are ways to use it. There are ways to secure it. If you don't need to use wireless connection, don't use it. Disable inbound access. Not all industrial control networks needs inbound and outbound traffic. Commandment 6. IDS Implementation. Intrusion Detection System Implementation. Establish an intrusion detection strategy. Intrusion detection system monitoring, such as Sparta, is essential 24 hours a day. Purchase ICS IDS, Industrial Control System IDS, because there is a totally different concept of corporate IDS and control system IDS. They have completely different mechanisms and concepts. Again, Sparta is used as a network IDS, and it has all DPI, deep packet inspection protocols inside of it. It shows all your network assets. It detects any deviation from the normal behavior of control network and not of IT network. Corporate IDSs protect different protocols, HTTP. They are designed for protecting mass traffic, unlike control system IDS that are designed for a specific network, small networks, specific protocols, Modbus, Profinet, Ethernet IP. All the HMIs are supported, so there is a big difference between control network IDS and IT network IDS. Incident response procedures must be in place to allow an effective response to any attack. Enable login on all audit systems logs daily to detect suspicious actions. Commandment 7. Auditing SCADA devices and networks. Technical audits of SCADA devices and networks are critical to security. The use of these tools will eliminate what I call path of the least resistance that an attacker could exploit. Analyze identified vulnerabilities to determine their significance. Retest systems after corrective actions have been taken to ensure that vulnerabilities were actually eliminated. Commandment 7. Documentation of critical SCADA functions. Develop and document a robust information security architecture. Documenting the information security architecture and its components is critical to understanding the overall protection strategy and identify single points of failure. In the displayed example, we can see one way of documenting the control system. Here we used Visio followed by Excel sheet to document all network assets. Commandment 8. Security assessment of physical and remote sites connected to the SCADA network. Any location that has connection to the SCADA network is a target. Control networks sometimes spread over a large area. So there are distant sites, sometimes with small unmanaged switch, that is very vulnerable. So you need to go there, identify if this can be hacked, if this can be exploited, maybe change it, maybe take it away and think of a different architecture. This is one example, there are many. Conduct a physical security survey and inventory access points. Identify and assess any source of information. Identify and eliminate single point of failure. Do not allow live network access points at the remote unguarded sites simply for convenience. Commandment 9. Establish effective configuration management processes. Configuration management needs to cover both hardware configurations and software configurations. Changes to the hardware or software can easily introduce vulnerabilities that undermine network security. Commandment 10. Last but not least, establish system backups and disaster recovery plans. Establish a disaster recovery plan that allows for rapid recovery from any emergency, including a cyber attack. In order to establish disaster recovery plan, you need to think how much time can you live when the system is down. If you need 1 hour, for example, if you have only 1 hour, for example, before you lose production, you need to take care of all the measurements, including purchase spare parts, spare PLCs, spare HMIs, spare servers, in order to replace it in that period of time, in that 1 hour. If you need 0 time, a system that does not allow even 1 second for a shutdown. Must have, for example, a redundancy for the servers, redundancy for the PLCs. We all know that, but now the concept is thinking from the cyber aspect. So maybe if you have a redundancy for servers and they are both being attacked, maybe you can think of third server to be offline and can be replaced immediately when crisis occurs. System backups are an essential part of any plan. Okay guys, that is my point of view of the 10 commandments of securing your control networks. We learned that control systems are vulnerable. There are many attacks on industrial control systems. There are many connections that need to be secured. There are many vulnerabilities in the control systems. The industrial control system, as we all know, is very vulnerable. Please take my 10 commandments. If you are a plant owner, take it to your plant and try to start with it as a baseline for securing your control system. If you are an integrator, implement it on your customers. And if you are a system integrator, implement it to all of your customers. Try to see where are the connections. Take the 10 commandments, review them, see if you have more knowledge. Currently, there is a lot of information on the web for securing industrial control systems. Take our commandments as a baseline and start implementing now. Thank you. Bye.